Hi everyone, welcome to today's video. We're gonna have a look at Intel and TSMC. And are we at the beginning of a shift, or let's say a bigger shift in the semiconductor manufacturing space, which also not only affects Intel and TSMC, but obviously would affect the likes of, AMD against Intel, or how competitive Intel is against, for example, NVIDIA in the AI GPU space. So this kind of discussion is gonna affect the entire semiconductor space, be it whatever kind of company that you are interested in. Essentially, any of these companies here. It could be Qualcomm. Imagine if Qualcomm shifts their Snapdragon mobile SoCs for for Samsung and so on from TSMC to Intel somewhere down the road. Well, obviously, this I don't expect to happen anytime soon. But if we start to see some kind of improvement for Intel's 18A and later on 14A compared to TSMC, which kind of start to in my opinion they're kind of starting to do some shady stuff. Like we've been seeing TSMC increasing their prices on packaging, on their wafers, on manufacturing all year, and essentially over the past 3-4 years, every single time, every 2 months you go in and you'll see that TSMC, they have increased their whatever kind of either packaging or manufacturing price. So now there's rumors of the 2 nanometer process wafers to be at 30,000 US dollar, and we will see that this is gonna to have a lot of implications for the industry. So first of all, you can see that I think this headline is very interesting. So according to Tom Swarter, Luna Lake allegedly smokes AMD's Z1 Extreme in handheld gaming. Now, to be honest, Z1 Extreme is a couple of years old now, but even compared to AMD's Strix Point, it looks like at 15 watts power usage, Luna Lake is much more efficient. Now, that's not a surprise to me. Remember that Luna Lake also includes a memory inside the chip. This helps with efficiency. It's produced on Intel, I think N3 on N3E, I believe, or maybe N3B. But anyways, it's one of the 3 nanometer derivatives of TSMC. And for example, AMD's Strix Point is on N4P, I think. So it's 20-30% more efficient and performant manufacturing node. So it's not only that it's a better design. It's also it's a more expensive but also better design than I would say AMD's Strix Point. That's still based on TSMC node, like 3 nanometer compared to a derivative of 4 nanometer. But let's have a look at, for example, this other headline. I think this is interesting. So the whole picture is not as easy as you might believe. On this, according to this data from Phoronix, when they did a lot of testing, they say that AMD's Ryzen AI 300 dominates Intel's Core Ultra 7 Luna Lake for Linux developers and curators. So remember, like, I think Luna Lake is more competitive in the GPU side for gaming, but AMD's Strix Point is much better in the multi-threaded workloads where you need some development tools or some video editing or whatever it could be. So in multi-threading workloads, AMD is still better despite being on a lesser node and kind of utilizing a lesser packaging. Remember that AMD still doesn't have on-chip memory, whereas Intel is the first x86 chips that follows Apple's M series, where you have your CPU, your GPU, your NPU, and your memory all on a single chip. And having that outside the chips gives you some freedom. For example, if you buy a laptop and you start with 16 gigabytes of memory, in some of the cases, if the manufacturers allows you, you can change to 32 gigabytes of memory. But if it's on a package memory like Luna Lake or like Apple's M series, for example, since Apple's M series launched, I think in 2020, you cannot change your memory. So, there's goods and bad things about anything. But going forward here, we can see that on the next topic, we can see that NVIDIA apparently there's rumors that NVIDIA is going to, utilize Intel's packaging rather than TSMC's. Well, that's not the correct way to put it, actually. They're gonna, in addition to TSMC packaging, maybe use Intel's, Foveros packaging, which is similar to TSMC's chip on wafer on substrate packaging. We also seen that Jensen Huang during the summer kind of hinted that they are, planning ahead for the supply chain in case something happens, be it geopolitically or whatever it could be with TSMC. So it seems like Jensen Huang has a backup plan for Nvidia's big chips. And the question is, what are the main possible outcomes in that scenario? Well, most likely it's Intel. So I wouldn't be surprised that at some point in the near 2 years we would see like substantial Nvidia business going through Intel factories. There's a lot of discussion about the actual health of Intel 18A. We know that they had some kind of troubles on 20A, so they kind of postponed everything, or actually like side put 20A and moved essentially everything to Intel 18A. And 18A to me looks promising right now. I'm not 100% sure, but it looks kind of promising. And we can see that, for example, one other interesting point, according to this guy on Twitter, by the handle of Everest, which I really like, you should give him a follow. He has a good point though, that, just because TSMC increases their prices on 18A, it doesn't magically make, Intel's process better. So yeah, we shouldn't, take anything for granted right now. Let's wait for more data. Speaking of more data, we know that Intel and Amazon, so their AVS, they kind of strike a partnership deal, which Amazon is gonna, utilize Intel's 18A for Xenon 6 chips, a special variant of Xenon 6, which is based on Intel 3, but also an AI chip that is based on Intel 18A. So, now we have seen rumors of NVIDIA. We've seen clear data to that Amazon is going to utilize Intel's manufacturing capability. Let's go back to TSMC. Remember this video about TSMC and Intel mainly, but that based on that conclusion, we will see that it's going to affect the entire semiconductor space. So we can see that TSMC, they're saying that they're confident that the 2nm chips will be produced in 2025 in volume. And to be honest, I think 2nm was supposed to be out already last year, or even maybe late 2023 if you go way, way back. But it kind of got postponed a bit, and it's getting more difficult, to hit the timelines as you go smaller and smaller on the transistor size. Remember, it's like insane amount of much more than rocket science that goes into manufacturing these chips, and on the production side from TSMC and Intel side, not only design from the likes of, let's say, AMD and NVIDIA. So I believe that TSMC is kind of slowing down a bit in their advances, in order to like maintain their whatever would be like every 2 years entering a new, let's say, generation of manufacturing for transistors. Now we've been stuck on 3nm for quite a while. Although that being said, we know that there's been a lot of discussions that customer demand for TSMC 3nm is insane. And even more so that the customer demand for 2nm seems to be even further insane, more insane than the same kind of timeline for the 3nm. So yet, I'm not, necessarily saying that there's any dark clouds on TSMC for the moment. It's just like maybe we start to see a bit more competition, which is good for everyone. Now, quickly, let's have a look at, the die sizes. Remember that TSMC works in mainly on the mobile side. That's how they introduce their newest manufacturing nodes, like be it 5nm, 4nm, 302, or so on. They start with, for example, Apple. Apple is usually, the launch vehicle for the launch product with their Apple small mobile chips for their iPhones and iPads. These are chips that are around, let's say, 100 square millimeters or so. And you can see based on that, on a wafer that is 300 millimeters in diameter, you should possibly have around 600, 600 dice per wafer. I'm going to, for example, let's take the Intel case. For example, let's go with let's say that Intel that is focusing on larger chips, although they also start with smaller chips. For example, their mobile laptop CPUs, like Meteor Lake was the launch vehicle for Intel 3nm, right, in last December. But yeah, so for Intel, if they're gonna, for example, focus on high performance computing, let's go with a chip that is, around 450, 500 square millimeters. You immediately see that, the number of chips per wafer goes from 600 or so at 100 square millimeters to, like 100 or so chips at 450 to 500 square millimeters. Now, and that's assuming a fully correct, yield density. Now, going to, for example, yield, let's say if we have, a defect density of 2%. In Intel's case, we know that, for example, as I mentioned, they are talking about Clearwater Forest. That is going to be the first high volume chip to be fabricated on 18A. Technically, it could also be Panther Lake, the successor to Luna Lake. But yeah, let's assume that 18A is also going to be very early on Intel 18A. And, Clearwater Forest is going to be, a big chip. The same way that, the previous generation, Sierra Forest, which launched early this year on Intel 3nm, we can see that Sierra Forest, the compute die is almost 600 square millimeter in size, according to Wild C on the Twitter, which I guess you should also get a follow. He's a really nice account. Let's go with 500 to 600 millimeter range, right? Now, that chip was manufactured on Intel 3 already this year, and they're competitive with, for example, products launched on TSMC's 4 nanometer, which is AMD's EPIC lineup. So it seems to be, doing fairly good. But remember, again, it's very different to launch a product on 600 square millimeter die compared to, for example, TSMC, which is going to launch, I don't know, let's say their 2 nanometer process with Apple's next generation A19, I guess, for iPhone 17, I guess, next year. I assume that, TSMC 2 nanometer will launch with Apple's iPhone 17 and the A19 chip. And we can see that that's gonna obviously be a much smaller chip, around 100 square, I assume 100 square millimeter. And you can see they get a yield of 82%, whereas Intel, with the same kind of logic, if they launch, their 18A on a 500 square millimeter die, they get a yield of 40%. So remember, Intel could easily, for example, go also with, 100 square millimeter die, and that would obviously give you a much better yield. Now, to be honest, not everything is equal there. For example, my suspicion is that TSMC's defect density is lower than Intel's currently, which means that even if Intel goes to, let's say, let's do it apples to apples. So let's go with Intel also launching, let's say, I don't know, 100 square millimeter die, but let's increase the defect density to 0.3. And how much will that affect? So you can see then Intel gets a 75% or so yield, whereas TSMC on a 0.2% defect density gets around 82. So it's still, quite substantial difference. But that's not the point. I'm not saying that Intel has surpassed TSMC right now, or they will do it next year or this year. But at least at the very minimum, not on the volumetrics, like in terms of number of chips and number of wafers manufactured from Intel compared to TSMC, at the smaller transistor nodes like TSMC 4, 3, and 2 nanometer compared to Intel 3 and Intel 18A. But what I'm saying that Intel 18A seems to close the gap substantially, and in some cases, be ahead of, I don't know, TSMC. Remember that if Intel launches, let's say Diamond Rapids on the server side, and also on the consumer, they maybe launch, I don't know, Panther Lake on 18A, both of these products for next year. They will be competing with, on the consumer side, let's say with no essentially TSMC 2 nanometer products. Other than iPhones next year, I don't believe that we'll see any 2 nanometer products out there. And that is, coming from NVIDIA or AMD. And that means that, Intel on the consumer side will have, I think, an advantage. Now, 18A, again, is not necessarily better than Intel 2, but the only Intel 2 product next year is Apple iPhone. You're gonna not see, AMD laptops with TSMC 2 nanometer next year. And you're not gonna see any NVIDIA GPUs on 2 nanometer. So that is the point. And again, going to the server side, it's the same kind of story. You're not gonna see AMD all of a sudden go to 2 nanometer, with next year's EPIC lineup. No, next year's EPIC lineup is going to be on 3 nanometer. And that is why I think, Intel is starting to kind of challenge TSMC somewhat. And all these price hikes is not going to be for the help of TSMC, trust me. But again, this is not, saying that Intel will just take the lead immediately. But I think, I find Intel at these prices very interesting. So yeah, thank you for watching. Please like and subscribe, and see you in the next one.